Hi everyone. So the next topic is two-stack PDA and a Turing machine. Okay. So we already know this two-stack PDA in the push-down automata. Okay. Now the concept is so let's go with the push-down automata. So push-down automata actually have a stack for storage purpose. Okay. So if you add a one more stack to the PDA, it will do more more storage, more works than the single stack PDA. Okay. So if you take a language like a power n, b power n, c power n, d power n, and where n greater than 0, these kind of languages cannot be accepted or processed by the single stack push down automata, but these can be actually done by the two stack PDA. Okay. So what is the difference between single stack PDA and two stack PDA means we added additionally one more stack. Okay, two stack PDA means two stacks are actually existing in the added to the PDA. Okay, where two stack increasing of stacks will also increasing the power of PDA. Okay, here obviously there is a question that is two stack or maybe more than two stack PDAs is strong as a Turing machine. That means both are equal, or PDA with more than two stacks is more powerful than Turing machine, or Turing machine is powerful than the PDA of two stack. Okay, there is always a question like that. So here we will clarify the question here. Okay, so for the purpose of answering, so an American artificial intelligence scientist Marvin Minsky proposed a theorem, that is Minsky theorem. Okay, so here the Minsky theorem defines any language accepted by a two stack PDA can also be accepted by some Turing machine as well as vice versa. Okay, so that means if a language, if you take this language, cannot accepted by the cannot processed by the single stack PDA, but this can be processed or accepted by the two stack PDA. In the same way, this can also accepted by the Turing machine. That means if any language accepted by a two stack PDA, that can also be accepted by Turing machine. If any language accepted by a Turing machine, that can also be accepted by a two stack PDA. So somewhere, not somewhere, actually these are similar, but here we have stacks. Okay. So general Minsky model is defined like this. So that means two stack PDA only. So infinite input step is there, reading head is there, finite control is there. In PDA we have only one stack, but here we have one more stack. That means simply two stack PDA. Okay. So the two stack PDA consisting input tape, read head, finite control under two different stacks, right? Like S1 and S2. Okay. So if you take a language A power n, B power n, C power n, where n is greater than or equal to 1. So what is actually happening there? First you have to scan A, and that can be replaced with that means that can for A you can push some x into S1. Okay, so that is actually the procedure of push down automata. While reading input tape symbol, and if the stack variable is matches, we can pop stack variable and we can push some stack variable and input into the stack. Okay, that is actually there in the push down automata. Here also we are performing the same. By scanning A, we can push x into the stack S1. Okay, again the continuation, if a stack top is x in S1, B is scanned and the symbol y are put into the stack S2. Okay, so A, if you read A as an input, you push x into S1. While reading B, if x is the top of S1, you can push y into S2. While reading C, x is the top of S1 and y is the S2. Those can be popped for the C. Okay, hope you understand. So this is the language. For traversing A, you can push x into S1. While traversing B, you should match x is the top of S1, then you can push y in the stack 2. For traversing C, if x is on the top stack S1 as a top symbol, if y is the top symbol of S2, then you can pop both for C. Okay, so like this you can utilize the two stacks for traversing these kind of languages which are not possible with the single stack PDA. Okay, so C two stack PDA can also accept these kind of languages like A power n, B power n, C power n, D power n, and A, B, C, D power n. Okay, so all these kind of languages is actually accepted by the two stack PDA only, not a single stack PDA. Okay, so two stack PDA, and these also can also accessible by this Turing machine. So from the previous examples you understand, so these kind of languages is actually accepted by the Turing machine, and that can also possible by the two stack PDA, not a single stack PDA. Okay, so let's go with an example. So here is an example. Design a two stack PDA for a language A power n, B power n, C power n, D power n, where n is greater than or equal to 1. Okay, so what you have to do? So previously we discussed now, A for traversing A, you can push two stack. Again we have a two stack. For A we have to push some symbol into S1. For traversing B, if x on S1, you can push y into B or S2. For traversing C, what you have to do is you can check the top symbol of S1, top symbol of S2, you can pop them, right? For traversing D, it's okay, you have to you can take one more variable z. Okay, here we follow different approach, that is for A, B, C power n, right? Here we have 4 now. So what we have to do is, for traversing A, x are put into the stack S1. For traversing B, with the stack x is on top S1, so x is popped from S1 and y is pushed into S2. For traversing C, y is in S2, y is popped from S2 and z is pushed into S1. For traversing D, z is popped from S1 and so z is popped from S1. Okay, so pushing, popping of a new stack variable is actually happening. For A, x is put into the S1. For B, x is popped from S1 and y is pushed into S2. For C, y is popped from S2 and z is pushed into S1. For D, z is popped from S1. Okay, these are the steps we have to follow for the language. Okay, so transition functions. So we are at a Q naught state. So lambda is nothing but like epsilon null string. So Z1, Z2. Okay, we have two stacks, right? Z1 is the initial stack symbol of S1. Z2 is the initial stack symbol of S2. Already they are actually in the stack. Okay. So if you are in the Q naught state and you don't have any input string, that is nothing but lambda or epsilon, whatever, null. Okay, what you have to do is, and Z1 is the initial stack symbol in S1 stack, and Z2 is the initial stack symbol on S2 stack. Then what you actually do is, you can transform out to state Q1 and you can push Z1 into uh, S1 stack Z2 into S2 stack. Okay, if you find A as input symbol in the Q1 state, and Z1 is the top of the stack, Z2 is the top of the stack 2, what you have to do is you have to stay in the Q1 state only. You have to push XZ1 into the stack 1. XZ1 means first Z1 can be pushed, and Z can be, X can be pushed next. Okay. Here Z1, Z2 are popped. Okay, if you are in the Q1 state, A is the input symbol, you can pop Z1 from S1, Z2 from S2. You stay in the same state Q1, and you can push XZ1. That means Z1 can push first and X can push next, and you can push Z2 into the stack 2. Okay, then if you are in the Q1 state and you have a same input again A, you can find X as the top of the S1 stack, then you can pop X, you can pop Z2, and you have to stay in the same state Q1. You can push X into the stack 1, you can push Z2 into the stack 2. Okay, now we are at a Q1 state. If you find a B, so A power n, B power n, C power n, D power n, right? Get greater than or always 1 means you can take 2n. So A square, B square, C square, D square. So 2A's, 2B's, 2C's, 2D's. Okay, A completed B. So you are in the Q1 state. You have a new input symbol B, and top of the stack you have X, and top of stack 1, and top of a variable of stack 2 Z2. What you have to do is you have to change the state to Q2. That means why? Because a new input symbol changed, no? Okay, so then you have to push nothing. Lambda means epsilon actually. You have to push nothing into stack 1, but you have to push YZ2 into the stack 2. Okay, now we are in a Q2 state. You have a B input again. If you find X on the top of the S1 stack and Y on the top of the S2 stack, you have to stay in the same state. You have and push nothing into the stack 1, but push YY into the stack 2. Okay, so then now you are at in the Q2 state. You have a new input symbol C. Obviously we go for state transition, and Z1 is the stack symbol, top stack symbol in the S1, and Y is the stack symbol in S2. Okay, top of the symbol. So you have to move to Q3, and you can push ZZ, and Z means Z is here is new stack symbol Z, and Z1 is initial stack symbol of S1. You can push those two into the S1, and lambda is nothing but epsilon into the S2 stack, pushing. Okay, so you are in the Q3 state. New input symbol C, Z on the top of the stack 1, Y on the top of the stack 2. You are in the same state Q3. You can push ZZ into S1, lambda into S2. So you are in the state 3. D is a new input symbol. Z is the top of the S1. Z2 is the top of the, only one symbol in the S2. Then you can, why? Because a new symbol now, C to D, new symbol. So new state transition, and nothing can be pushed into the S1. Z2 can be pushed into the S2. So Q4, D is a new input symbol, Z is the top of S1, Z2 is the top of the S2. Q4 state transition, lambda can be pushed into the S1, and Z2 can be pushed into the S2. Okay, so finally you are in the Q4 state, and we have, so it means with the lambda we started. a square, b square, c square, d square, and we end with a lambda, new symbol. So this is actually 2 PDA. Okay, not a Turing mission. If it is a Turing mission, it cannot accept a lambda or a epsilon. Okay, so it is actually 2 stack mission. So what we are trying to say is more than one stack PDA is the same as a Turing mission. To prove that, we took this example. Okay, these kind of languages is actually accepted by only Turing mission, but that can also be possible with a 2 stack PDA. Okay, సో మీరు యాక్చువల్గా అసైన్మెంట్ కూడా రాశారు, మీకు అర్థమయ్యే ఉండాలి మరి ఏం చేశారు. ఓకే, సో వీఆర్ ఇన్ ద Q4 state. Lambda is the input symbol, end of the string, and Z1 is on the top of the S1, Z2 is the top of the S2. So finally we transform it to Q final state, and Z1 pushed into S1, Z2 is pushed into the S2. So final, we reached the final state, right? So in PDA we have two options, when we reach the final state or we empty the stack. Okay, so this is nothing but accepted by the final state. Why? Because we reached the final state. Okay, so from Q0 to QF we traveled entire input string, and we reached the final state. So that is nothing but so 2 stack PDA accepted by final state of this language.